Directory services exist to centralize identity information and access decisions so that organizations are not forced to manage users, systems, and permissions in isolation. Instead of each application or server maintaining its own view of who exists and what they can do, a directory provides a shared source of truth that other systems can rely on. This centralization is what makes large environments manageable, because it allows authentication, authorization, and policy enforcement to be applied consistently. From a security perspective, directory services are foundational infrastructure, since compromise or misconfiguration at this layer can ripple outward to affect nearly every system. Understanding how directories work and how they are protected is therefore essential for anyone responsible for enterprise security. Before we continue, a quick note. This audio course is a companion to the CISS books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series.
Lightweight Directory Access Protocol is the standard protocol used to query and update directory information, defining how clients interact with directory servers. It provides a structured way to look up identities, groups, and attributes, and to modify those objects when permitted. Lightweight Directory Access Protocol is intentionally flexible, supporting hierarchical organization of entries and extensible schemas that allow directories to store many kinds of information. That flexibility is powerful, but it also means that access controls and query permissions must be designed carefully to avoid exposing sensitive data. Lightweight Directory Access Protocol itself does not define who is allowed to do what, it provides the mechanism, while security depends on how authentication, authorization, and transport protections are applied. In practice, most directory interactions in enterprise environments rely on Lightweight Directory Access Protocol, whether directly or through higher-level services built on top of it.
Active Directory is a specific implementation of directory services that combines identity storage with domains, trust relationships, and policy enforcement. It extends the basic directory concept by integrating authentication services, authorization logic, and centralized configuration management. Domains define administrative boundaries where objects share a common directory and security policies, while trusts allow authentication to be shared across domains or forests. Active Directory's design reflects the needs of large organizations, where identities and systems must be managed at scale while still respecting organizational structure. Because Active Directory is so tightly integrated into operating systems and applications, it often becomes the backbone of enterprise identity. That central role also makes it a prime target for attackers and a critical focus for defenders.
Directory objects represent the entities managed within the directory, including users, groups, computers, and service accounts. Each object has attributes that describe identity, status, and relationships, such as usernames, identifiers, group memberships, and security settings. Users represent human identities. Computers represent managed systems, and service accounts represent applications or automated processes. Groups provide a way to collect objects together so that permissions and policies can be applied collectively rather than individually. The structure and naming of directory objects matter because they influence clarity, manageability, and the ease of auditing.
Poorly organized directories quickly become difficult to understand and secure, even if the underlying technology is sound.
Group membership is one of the primary drivers of authorization because it allows roles and permissions to be mapped to collections of identities. Instead of granting access directly to individual users, systems grant access to groups, and users inherit those permissions through membership. This approach simplifies administration and supports role-based access models, but it also introduces risk if group sprawl is not controlled. Over time, users may accumulate memberships that no longer reflect their current responsibilities, leading to excessive access. Nested groups can further complicate understanding, making it harder to trace why a particular user has a given permission. Effective group management requires discipline, documentation, and regular review to ensure that authorization remains aligned with intent. Domain controllers are the servers that host directory services and perform authentication, issuing tokens that users and systems present to access resources. When a user logs in, the domain controller verifies credentials and generates an authentication token that contains identity and group information. That token is then used by other systems to make authorization decisions without re-authenticating the user each time. Because domain controllers play this central role, their availability and integrity are critical to the entire environment. If domain controllers are compromised, attackers can forge identities, escalate privileges, and persist undetected. Protecting domain controllers therefore requires strong access controls, monitoring, and isolation from less trusted network segments.
Trust relationships connect domains and forests, allowing authentication to be recognized across administrative boundaries. Trusts enable users from one domain to access resources in another without maintaining separate credentials, which is essential in large or federated organizations. These relationships can be one-way or two-way and can span entire forests depending on design. While trusts provide convenience and scalability, they also extend the security boundary because compromise in one trusted domain can potentially affect others. Designing trusts requires careful consideration of which identities should be accepted and under what conditions. From a defensive standpoint, trusts should be minimized and monitored because unnecessary trust paths increase the potential attack surface.
Group policy is a mechanism within Active Directory that enforces configuration settings and security requirements across systems in a centralized way. Through group policy, administrators can define password rules, security settings, software restrictions, and many other controls that are applied automatically to users and computers. This central enforcement is powerful because it ensures consistency and reduces reliance on manual configuration. However, it also means that misconfigured or malicious policies can have widespread impact quickly. Group policy objects must therefore be protected, reviewed, and tested carefully before deployment. When used responsibly, group policy is one of the strongest tools for maintaining a secure and standardized environment. Replication is the process by which directory changes are distributed among domain controllers to keep information consistent. Because directories are often deployed across multiple locations for availability and performance, replication ensures that updates to users, groups, and policies propagate throughout the environment. Replication traffic must be protected to prevent tampering or interception, because unauthorized changes at one controller can spread rapidly. Replication conflicts or failures can lead to inconsistent state, which complicates troubleshooting and can create security gaps.
Monitoring replication health is therefore a security concern as well as an operational one.
A healthy replication topology supports both resilience and trust in directory data.
Directory security depends heavily on protecting privileged groups and enforcing proper delegation controls.
Certain groups have extensive powers, such as the ability to modify directory objects, manage policies, or control domain controllers themselves. Membership in these groups must be tightly controlled and reviewed regularly, because abuse or compromise has far-reaching consequences. Delegation allows specific administrative tasks to be assigned without granting full control, which supports least privilege when implemented correctly. Poor delegation practices, however, can unintentionally grant more authority than intended. Securing directory services requires understanding exactly who can change what and ensuring those permissions match organizational intent.
Kerberos is the authentication protocol commonly used in Active Directory environments, relying on tickets and cryptographic keys rather than transmitting passwords repeatedly. When a user authenticates, Kerberos issues a ticket that can be presented to services to prove identity without resending credentials. This reduces exposure of passwords and supports mutual authentication between clients and services. Kerberos depends on synchronized time and secure key management because tickets are time-bound and cryptographically protected. Attacks against Kerberos often focus on ticket theft or misuse rather than password guessing alone. Understanding Kerberos behavior is essential for diagnosing authentication issues and recognizing advanced attack techniques in directory-based environments.
Lightweight Directory Access Protocol over Transport Layer Security is used to protect directory queries and credentials from interception.
Without transport protection, directory traffic can reveal sensitive information or expose authentication material to anyone who can observe the network. Using encryption ensures confidentiality and integrity of directory communications, which is especially important when directories are accessed across networks or from remote systems.
Proper certificate validation is necessary to prevent man-in-the-middle attacks that could intercept or alter directory interactions.
Enforcing secure transport is a baseline requirement for directory security, not an optional enhancement.
When lightweight directory access protocol traffic is consistently protected, it removes an entire class of passive and active attacks. Auditing is the mechanism that records authentication events, group membership changes, and administrative actions within the directory. These logs provide visibility into how identities are used and how directory configuration evolves over time.
Auditing supports incident response by allowing investigators to trace account usage, privilege changes, and policy modifications. It also supports governance and compliance by demonstrating that controls are being enforced and monitored. Without adequate auditing, directory services become opaque, making it difficult to detect abuse or explain failures. Strong auditing turns directory infrastructure into an evidence source rather than a blind dependency. Directory services provide the backbone for identity, policy, and access control in many environments, making their security foundational rather than optional. Protocols like Lightweight Directory Access Protocol enable structured interaction, while platforms like Active Directory integrate identity, authentication, and policy enforcement at scale. Objects, groups, and trusts define how access is granted and shared, and domain controllers enforce those decisions through authentication tokens. Replication, group policy, and Kerberos add power and complexity, requiring careful protection and monitoring. When directories are designed and governed well, they enable consistent, auditable security across systems. When they are neglected or misunderstood, they become single points of failure with enterprise-wide impact. Episode 80, Multi-Factor Authentication and Implementation 1. Intro. MFA combines factors to strengthen identity assurance substantially. 2. MFA reduces risk from stolen passwords and reused credentials. 3. Common methods include app-based codes, push prompts, and hardware keys. 4. Hardware security keys support phishing-resistant authentication with strong cryptography. 5. Push-based MFA requires protections against prompt fatigue and social engineering. 6. SMS codes have weaknesses related to SIM swaps and interception. 7. Enrollment needs identity verification and secure binding to the user account. 8. Recovery options must be controlled to prevent bypass through resets. 9. MFA policies vary by sensitivity of systems and privilege level. 10. Conditional access uses context like device health and location signals. 11. Service accounts and automation require alternate approaches to MFA enforcement. 12. Logging and monitoring detect bypass attempts and unusual MFA activity. 13. Integration across applications reduces inconsistent user experiences and coverage gaps. Conclusion: MFA implementation succeeds when enrollment, recovery, and monitoring are strong. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.